Hello everyone, welcome back to Code with Cougar. In this video, we're going to talk about arrays, data structure, and also some concepts about memory management and also how data are stored in our memory. So let's get started. Arrays data structure is basically one of the most fundamental and widely used data structures in computer science. It is essentially for anyone looking to delve deeper into programming and algorithm design. So basically, they are a collection of items stored in contiguous block of memory or memory locations. So basically, the idea behind using an array is to store multiple items of the same type together. Remember, there are two main properties of array. The array elements or items are stored in a contiguous block of memory, one after other, and also in almost most of the programming languages, arrays store items of the same type. So we cannot combine different types to store them in array. For example, we cannot store collection of integers, characters, strings, etc. into one array. So the array elements should be of the same type. Other thing, as we spoke in the previous video, is that arrays have fixed size. Once we define the size of the array at the compile time, so we cannot resize the size of array, either shrink it or expand it at the runtime. So when we say int, before we start talking with about arrays, let's see how the data or a single data are stored in computer memory. Suppose I want to store number 5 in a variable n equal to 5. So what will happen behind the scene and how this 5 is stored in memory? If I wanted to print 5, so I can easily do that, and 5 is printed. But when I assigned another number here, says 8, so the 5 is overwritten. Now this memory address or memory location stores the value 8. Now let's take a look how this number 8 or number 5 is stored in memory. So here I have a visual representation of memory structure. This represents a memory of size 16 MB, starting from 0 going all the way to this 16 MB, which is this much of bytes. So basically, it's made up of small, tiny cells, where each cell represents one bit of information. So basically, a bit is the smallest unit of representation of data in computer. When we store number 8 or 5 here, in most of programming languages, we know that integer type or integer data types take 4 bytes of memory locations. We know that 1 byte equal to 8 bit. Also, so 4 byte will be 4 into 8, 32 bits. So each integer value in most of programming languages take 32 bits or 32 cells of memory locations. Here we can say a bit is either 1 or 0, which represents the data, and also a bunch of bits or 8 bits equal to 1 byte. When we store an integer value, so 32 bits or 8 bytes of memory location will be allocated for that variables. So this is byte 0. All these cells, consider all these cells as 32 bits or 32 cells where our data will be stored. In this case, integer 8 will be stored. So this chunk of 8 bits represent the first byte. This is the second byte or byte 1, byte 2, and byte 3. Totally 4 bytes constitute 32 bits, which is used to store an integer value. So when we store number 8 in our computer, basically number 8 is converted to binary form of 32 zeros or ones, and those 32 zeros or ones will be stored in these memory locations. So let's see, when we store number 8 here, I have used this website to convert an integer 8 to 32-bit binary form. So if we change 8 into its binary form, it's going to be a bunch of zeros and 1 1 then 0. So 8 will be stored or represented in memory location like this. So all these zeros will be stored in these memory cells, and 1 will be stored here, then 0 0 will have. Same case if we want to store another number, say we say int 65 or 700, let's say 789. So basically 789 will be stored in memory like this. It will be converted to 32-bit binary form, which is a series of 32 bits, either 0 or 1. So it is 4 block of 8 bits, one byte, 2 byte, 3 byte, and 4 bytes, since an integer value takes 4 bytes of memory location in most programming languages. However, we know that the smallest unit of data representation is a bit, but computers handle data as a combination of bits. In this case, we saw as a combination of 8 bits, which is 1 byte. So a group of 8 bits form a byte. One of the smallest unit of data is handled by the computer to calculate or process our data. Also, a word can be a group of 2 bytes or 4 bytes or 8 bytes. In this case, when we store an integer value, it's basically a group of 4 bytes, which is indeed 32 bits. So there are two primary mechanisms for data storage in a computer system. We have volatile memory like RAM, and we have also non-volatile memory like hard drive or SSD drive or flash drive. So basically, a volatile memory or RAM, this type of memory is often referred as working memory of the computer. The data stored in the RAM is temporary. It disappears when the computer is powered off or restarted. When we store int n equal to 8, so basically this in 8 value 8 is temporarily stored in RAM memory. But when we close this IDE, this value will be disappeared from the memory, since it is a non temporary storage. RAM basically allows data to be read. RAM basically allows data to be read or written rapidly, significantly improving the computer's performance. So one of the reasons we use RAM in our computer system is because it is very fast and it is closer to processor, and processor can access data from RAM very frequently and compared to non-volatile memories like hard drive or SSD drive. Non-volatile memory like flash drives or SSD drives, uh, these devices maintain the information even when the power is lost. So these are kind of permanent storage devices, making them ideal for long-term storage of data. They are mostly slower than RAM when it comes to reading and writing data. That's why when we open an application, so this OneDrive application is open right now. Uh, Typically, this OneDrive is installed, all the settings are in the SSD drive. But when I open this OneDrive application, it will be copied to the RAM so that the processor can access that read and write data to this application very frequently and very rapidly. That's why we use RAM in our computer system. So mainly there are two types of storage mechanisms in computer science. We have permanent storage mechanisms. Also, we have temporary. When we store our images, our files, documents, videos, etc., that will be permanently stored in SSD drive or hard drives. But when we open an application, like I have opened Google Chrome here, so that application will be opened in RAM so that it is easier for a computer processor to access that, read and write to the data very rapidly, since the speed of RAM is very much faster than the speed of reading and writing from SSD or hard drive. Let me open my task manager and see. I have opened Google Chrome, Microsoft OneNote. So Google Chrome is taking like 496 MB of RAM. Microsoft OneNote is opened and it took like 179 MB of RAM. Like same case, Visual Studio is open. it took about this much of MB. So if I close my uh, Google Chrome here, so it is gone from my RAM, and all the data is wiped out. So I have no more uh, instance of Google Chrome showing in my memory. So this way we could easily store an integer value in our computer memory. But what if I wanted to store another integer value? I can define another variable of type integer and store another value. Say I want to store 4. If I wanted to store another value, I can define a separate variable for that and store 90. So this way I can store multiple values in different variables. But what if I wanted to store like thousands or 10,000s of values? Defining separate variables for each value is going to be a tedious way, and that's not a good programmatic uh, practice. So for that, we have collection types or data structures like array data structures. To store a collection of integer values, I can simply define an array. To define an array, first I'm going to give the type of value I'm going to store in my array. In this case, I want to store integer values. Then I will give a square bracket denoting that this is going to be an array. And then I'll provide the array name. I can directly assign values to my array. So there are basically two ways to define an array. One way is to give the array name and directly assign values to array. The compiler in this case will decide the size of array based on the values we provide. So we provided 4 values here. So the compiler will assign size 4 for this my array. The second value is the second way of defining an array is that we explicitly say the compiler the size of our array. Say I want my ARR2 equal to new int of 3. So here we say the compiler that I want to define an array of size 3. So in this case, we can store 3 values in this array. So when we define an array, the compiler basically allocates a block of memory. Say I want to store 3 values, so the compiler will allocate a block of memory of 3 blocks of memory. So this is going to be my ARR 2, the name of array. As we know, the array index starts from 0 and goes all the way to n minus 1, where n is the size of array. In this case, our size of array is 3, so the index value will go to all the way to 3 minus 1, which is 2. So since it starts from 0, 0, 1, 2. Here in this blocks of memory, I can store different integer values. Say I want to store 3 here, 4 here, and 7 here. So each block of memory, this is going to be 4 bytes. 4 bytes here and 4 bytes here. Totally 3 into 4, since our size of array is 3 and each integer value takes 4 bytes, 3 into 4. So 12 bytes of memory locations will be allocated to my ARR2. We also know that each byte is equal to 8 bits, so 4 bytes is going to be 32 bits. So each cell or location of an array is going to take 32 bits of memory location, which is going to be either 0 or 1. So also we know that array elements are stored in contiguous blocks of memory. Suppose we have an array of size 3. 0, 1, 2, 3. So the index values start from 0, go all the way 1, 2, 3. So each cell will have its own memory address. We know that memory addresses are represented in hexadecimal form, but in this video, for simplicity, let's think that a memory address of the first block of memory is, say, it's 100. So the next block of memory is going to be 104, since each cell of the array is going to take 4 bytes of memory location. Then the next memory location address is going to be 108. This way we know that all the array elements are stored in a contiguous block of memory. So the contiguous memory location of array items makes it easier to calculate the position of each element by simply adding an offset to the base value, which is the memory location of the first element in array. In this case, the base value is 100. If we wanted to, let's say I want to store 7 here. If we wanted to access number 7, we can easily access this number 7 by adding an offset to the base number. So if this is ARR, say this array name is ARR, so ARR will store the base address, which is 100. So from 100 we can calculate the address or index, the location of other values. Say I want to access number 7 here, so using the base address, since base address is stored in the array name, I can do base address, which is 100, into the size of type of data which we store, in this case which is integer. The size is 4 byte into this is going to be plus 100 plus 4 into the index value of the number we want to access. In this case we want to access 7. The index value of 7 is 2, so 4 into 2 is going to be 8. So the memory address of number 7 is going to be 108. Same case, if we have another number here, say number 10 is stored here, the address of, to calculate the address of number 10, to access 10, we can do it using its index value. So the base value is 100 plus 4 into 3, which is 12. So 112 will be the address of a number 10 in our array. So this address is going to be 112. This way it makes it easy to access elements of the array. So I want to access number 4 here. In that case, I can access that easily by its index value. So I want to print number 4. So I say my ARR. I give a subscript and the index value. The index value of 1 is 0, 1, 2, and 3. The index value of 4 is 3. So I just give its index value. I can simply access an element from an array. It prints 4. So since we randomly access the elements, so the time complexity of accessing an item from an array is going to be constant, and it's very fast. We don't have to traverse over the array, and we can directly access each element by providing their index number. So there are some properties about array to remember. Array share the same data type, means that all elements of array should have same data type. They are stored in contiguous block of memory, and also items of the array are accessed randomly. So this was a quick introduction to array data structures. Thank you guys for watching, and see you in the next video. Bye bye.